When Einstein was a teenager, he imagined going so fast that he could grab light, but later he found that neither experiments nor math allowed for light to ever be still. The math that was used to determine the speed of light never specified what the speed was relative to, so Einstein took it as being relative to everything. This realization that light sped away from everything equally, regardless of the velocity of the object, has far-reaching effects and is known as the theory of special relativity. If you could measure how fast the beam of light from this laser is going while standing still, you would see it zooming away from you at 670 million miles per hour. But if you climb aboard this rocket and it blasts off, the speed of the laser seems to stay the same. How could that be? The only way for that to work is for time itself to slow down, but only for you. Now, if you look at a clock on the rocket and a stationary clock speeding by, you would see the time going by on the stationary clock faster than the clock next to you. No, the clocks aren't broken. Time is actually slowed down for you so that the light still speeds away from you at the same 670 million miles per hour. On the other hand, when you look at the rocket while standing still, you would see the rocket is moving like you would expect, almost keeping up with the beam of light. But if you look closely, the clock on the rocket is barely moving compared to yours. If you think about it, you know that time looks like it's going faster outside from the perspective of someone in the rocket, so that light has time to fly away at the same 670 million miles per hour. So it would follow that if time went by normally outside, then the rocket's clock would be going much slower than normal. This is a major part of special relativity. It's where the relativity part comes in, actually. Even though you are looking at the same thing at the same point in time, you are moving at different velocities and time is going by at different rates. That makes the scenes look much different, but they're only different relative to each other, and they are both correct. Now we need to turn around, so we'll circle around this black hole and head back. Now it's taken this long to get out here to the black hole, but we want to get back faster. So let's speed up to even closer to the speed of light. Now time for us is going so much slower, or you could say everything else was going much faster, that we get back in a few seconds rather than the minutes it took to get out here. Now that you're back, you realize that time outside your rocket has been going much faster than you thought this whole trip. So you check the time and date, and find out it has been 2 weeks since you left, even though it only feels like a few minutes to you. Since how fast you go through time depends on your speed, going faster causes you to travel through time. And that, my friends, is special relativity in a nutshell. I hope you enjoyed it and have a great day.